All right, today we are going to be doing the mechanical energy practice worksheet. This is problem number 1. Yesterday or the last night, you worked with the conservation of energy. We worked on the energy skate park simulator and that picture worksheet that showed how energy cannot be created or destroyed. It can only be transferred. It can be transferred into other types, such as heat through friction. Potential can go to kinetic. Kinetic can go to heat. A variety of different transformation, but all mechanical, so all having to do with some type of motion or position of an object. This problem today we will be working on says the largest watermelon ever grown has a mass. For all of these, we should be, our picture is helpful. So here's the watermelon. It has a mass of 118 on a platform above the ground. So here's my platform. Here's the watermelon, 118 grams. I do not like, oh no, kilograms. That's good. Kilograms are good. We'll keep kilograms. Suppose the watermelon was a height of 5 meters above the ground. After the exhibition, the watermelon is allowed to slide down the ramp. How high above the ground is the watermelon at the moment its kinetic energy is? So we're going to solve for some amount of height above the ground that the watermelon will be when it has kinetic energy of 4.61 kilojoules. We do not want to work in kilojoules, so we want to convert those to joules, which would be 4,610. Before we start this problem, you'd want to do a little bit of just kind of analysis and thinking about the problem and what type of energy is at each location in the problem. So at the top, we know that the object has all potential energy and it has no kinetic energy. At the bottom, if we have set the ground to be our potential energy equal to 0, which is a good thing to do, it's a easy location to work with, we know that the potential energy at the bottom is 0 and the object has all kinetic energy, whatever that value is. I think that I have enough information to solve for the potential energy at the top, which is the formula mass times gravity times height. So potential energy at the top, which is the total energy at the top, nRG, should be equal to the energy everywhere else in the motion of the watermelon. So I should be able to pick any other location along the motion of the watermelon, and the potential energy at the top should be equal to the total energy at that location. Because the question is asking for when the kinetic energy is 4.61 kilojoules, I'm going to set the total energy at the top to be equal to the total energy at that location. And so the types of energy at that location are kinetic energy, and I'm just going to call that midpoint, plus the potential energy at that midpoint because it is still above the ground. Well, now I can put in formulas for this. Mass times gravity times height for this spot, and this location has kinetic energy, which is 1/2 mv squared, plus mass times gravity times height, but beware that this is not the same height as at the top, and so that is not going to be the same value. So I know my mass is 118 kilograms, gravity is 9.81, and my height at the top is 5 meters. Make sure you're all in SI units. My kinetic energy I was given, and it's 4,610 joules there at the midpoint, plus the mass at the midpoint, which is still 118. It did not lose mass as it slid. Gravity is still 9.81, and I'm solving for this height at the mid. This is at the mid. Get that out of the way. So looking at this equation, I only have one unknown variable, and so I should be able to solve for the height at that spot by multiplying all of my left side of the equation, subtracting the 4,610, then dividing by my 118 and my 9.81, and I should get height at that mid spot of 1.02 meters. Good luck solving the next problems, and all the answers are in parentheses, so you should be able to check your work.